Okay, welcome students. This is Mr. Yi again. We've got a video that's going to help you review for the quiz that we're going to have tomorrow. This is over 4.4a, so it's over the graphing linear equations and also graphing linear rates of change. So we haven't done this first page. Has to do with the graphs where we have a diagonal line that goes from this corner to this corner, and then we figure out how much money something is changing per week, and then there's a couple of other additional questions that's asked a little bit later. So let's go ahead and get started. Let's read our directions first. It says graph the data and find the rate of change. Be sure that your rate of change is labeled with the correct units of measurement. Answer any additional questions. So it says Kevin's savings account balance changed from $189 in 5 weeks to $1,325 in 29 weeks. Answer the questions and show your work. So first of all, it says part A, find the rate of change per week. And we're supposed to use this formula here. So we're going to be doing this by subtraction rather than by counting the vertical and horizontal distance. So dollars minus dollars, and then weeks minus weeks. So if we come up here to the top, we can see that $189 in 5 weeks, that's one set of ordered pair. The other ordered pair is $1,325 in 29 weeks. So those are the things that we have to use here. So dollars minus dollars, so we're going to take 1325 minus 189, and then we'll take 29 weeks minus 5 weeks. Now you can see that these two ordered pair are written together going vertically, and these two ordered pair are written together going vertically. So make sure that you don't get these mixed up where you have the 5 underneath the 1325 and the 29 under the 189. So make sure you keep these ordered pair together going vertically in this formula. So 1325 minus 189 gives me $1,136. And then 29 minus 5 gives me 24 weeks. So that's how much it's changed over 24 weeks. And now what we want to do is change this to 1 week. So to do that, we're going to divide the top by 24. Because if I divide the bottom by 24, that gives me the 1 week that I want. So we go ahead and do that. 24 divided by 1136 gives me $47. And then I get $47 in 1 week. Spell week very good. Okay, so now we've got that done. Next thing it asks us to do is to complete the graph savings. There's a D there, and that D means a dependent variable, and the dependent variable is always on the y-axis. So it's vertical, versus weeks, which is the independent variable, which goes along the x-axis. So complete the graph of savings, D versus weeks, by using the amount saved per week. Start the graph at 25 weeks and $1,325. So let's go ahead and label our graph. We want this one to be weeks, and the vertical one here to be dollars. We're ready to go. Now one thing that we have to find out here is how we want to count. You know, we're starting here at 25 weeks, and we're starting here at $1,325. So do we want to count every 1, 2, 3 weeks, every 1, 2, 3, 4 weeks, or every 5? You can decide how far you want to count. But remember, each time you go over 1 week, you go up $47. So if I go over to 27 weeks, then I would go up $92. Okay, so I would have a unit here. Now what I'm going to do, and you're free to do whatever you want, I'm going to count mine in units of 4. So 1, 2, 3, there's 4 weeks. 1, 2, 3, there's 4 weeks. 1, 2, 3, 4 weeks, 1, 2, 3, 4 weeks, 1, 2, 3, 4 weeks. So each one of these are going to be worth 4 weeks. So that means I'm going to come up here, 4 units, 4 units, 4 units, and then it makes me a nice perfect square, right? Square units, because we're dealing with perfect rates of change. Okay, so now my graph's kind of laid out. So I'm going to go 4, 25 plus 4 will give me 29. Add 4 more will give me 33. Add 4 more will give me 37. Add 4 more will give me 41. And then add 4 more will give me 45. So 45 weeks. And now here, let's see what we've got here. I know I've got $47 per 1 week. And I want to know what it is for 4 weeks. So I'm going to take 4, that's multiplication by 1, so I'm not changing how much it's changing at the same rate over 4 weeks. So 4 times 47 will give me $188 that it's increasing every 4 weeks. So from here I add 188, 188, 188, right? And these down here, I added 4 weeks each time. So let's go ahead. I'm going to pause my video. What I'd like you to do is take your calculator, and each one of these you're going to go up each increment $188, and then figure out what your labels here are going to be. So I'm going to pause my video, you do yours, and then we'll go back when I restart the video, and then you can see how things. Okay, I finished labeling my graph. So every week down here goes up 4, and all the money here goes up in increments of $188 for every 4 weeks. And so if you follow this over, every 4 weeks it goes up that far. Every 4 weeks it goes up, and if you've done your graph right, every 4 weeks we should end up right here at the top corner. So if you've counted it right, you should have a nice diagonal line. I'm going to go ahead and draw my diagonal line here. I'm going to let me clean up my graph just a little bit. Get rid of this right here. So take your ruler and draw your diagonal line. It goes through the, cut your graph in half. Pencil out here. I've got an eraser on. Oops, I lost my ruler. There we go. So that's what your graph should look like, right down the center. So you'll be given some points for finding this. You'll be given some points for using this formula correctly. You'll be given points for figuring out your units, and then most of your points will come from doing this graph correctly. Okay, now it says use a graph to predict how many weeks it will take Kevin to buy a used car that costs $2,750. Well, we don't have a graph that goes up that high. So what I'm going to do is let's just change this. I meant to change it before I started this video and I forgot. Let's say that we want to find it for $2,200. So if I come up here along the side here, I know that $2,200 is right here. Every one of these is worth 47, correct? So what is that one right there? So if I take 2265, we know each one of these is worth 47. So 2265 minus 47, that'll give me 8, 1. 2218 is right here on this line. That's pretty darn close to $2,200. So I'm going to take this line And that's what I'm going to use to estimate. Why don't I use a blue one? Take my ruler again. And so I'm going to use this graph to estimate. So I follow it over there to that line. Color here. I don't know why it's not writing. There it goes. Goes over to there. And then I want to swing that down. Now your units may be different from mine, but the graph should still read the same. You should still come up with the same answer. So at $218, about $2,200, it hits this line, and now when I hit that line, I follow it down this way, it hits right there on the graph. Now, each one of these is 1 week, so it'd be 37, 38, 39. It looks like 40 weeks. That's how long it would take him to save $2,200. So some key points that you need to remember how to do is how to use this formula right here. Make sure you know how to use the formula. Make sure that you label your graph correctly as far as the independent and dependent variable. Make sure that you do your units correctly, and remember you can do them any way you want, but it has to be based upon what you come out with right here. So you're going to use this to figure how far you're going to jump across the bottom for each tick mark for each large unit, and then you're going to use this $47 to decide how much you're going to do here. And then use the graph to predict how many weeks it'll take to earn so much money. Here you estimate where that is along the dollars. You follow that over to where it hits the line, and then from when it hits the line you follow it straight down to the x-axis, and then you read that unit off right there to get your final answer. Okay, so this is all we have for question number 1. I'm going to let you do question number 2 on your own. I'm going to pause the video here for just a second, and then I'm going to set up some stuff on the back side of the quiz. So let me pause this. Okay, you should be on the back side, and we're starting with problem number 3. It says list the ordered pairs for each of the points on the graph and find the slope for each of the line segments. So let's take this kind of slow. And so let's look at point A now. Remember, you always start counting from the origin. That's this point right here. And you count on the x-axis. You don't count this as 1, this is 0. So that's 0, and then you go 1, 2, 3, 4, 5. That's 5 on the negative x-axis because I'm moving to the left. You also can count the squares rather than the tick marks. So 1, 2, 3, 4, 5 squares. And now I want to go up 1, 2, 3, 4, 5, 6, 7. And that's going up. It's in the positive on the y-axis. So that point is a negative 5 and 7. And that's point A. Let's go down and let's look at point F. So on the F is down here. So I start on the x-axis. Let's just count the squares. 1, 2, 3, 4, 5, 6, 7 on the y-axis, and that's a positive 7. And then I go down 1, 2, 3, 4, 5, so that's a negative 5 on the y-axis. So that's the ordered pair for those 2 points, and so you'll finish the rest of those. Now we'll find the slope. And remember, the slope is how flat or how steep a line is. So if we look at the points, let's do this big one here. We're going to do from B down here to F. So what I like to do is just kind of try to make a triangle Goes from there to there, and then I draw the horizontal and vertical distances here. There's the vertical distance. I go over for the horizontal distance, and then I count the length of these sides. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're doing BS, so that's 10 on top. And I'm going in the negative direction. I'm going down, so that's a negative 10. And now I count positives, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 in the positive direction. Now that will simplify. Negative 10 over 14 will simplify by dividing 2 into 10 and 2 into 14. So that is a negative 5 over 7 should be your final answer for that one right there. Box that. Okay. All right, let's do one more. Let's do this in blue. Let's do E and C. So I'll draw there's a line segment that I want to find the slope to. Now I'm going to draw the vertical line, horizontal distance, and the vertical distance, and then I'm going to count up my sides. So it's 1, 2, 3, 4, 5, 6. You can count that going down if you want. This is CE, so that's a negative 6. And then from here I count back 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 6 over 10, that divides by 2, divides by 2, so that is 2 over 5. It's 2 over 5 because it's negative divided by a negative. It's a positive. Another thing that you can realize is that anything that slants upward from left to right, it's going up from left to right, will always be a positive slope. So if you just want to count your numbers, count up your sides, write them in, and then take a look at what the slope is. This is a negative slope because it goes down from left to right. Then you can put your signs in later if you want. Okay, enough of that. So let's move on to the next part here. It says find the slope between each ordered pairs and then decide if the points are linear. So if I look between 6 and 3, that goes down by 3. Make sure you put the negative sign there. This goes down by 3. This goes down by 3. This goes down by 3. Now if I count it this way, if I count it that way, these things go up by 3. But if you count them going up this way, you got to count those going up this way. Your signs are going to be backwards on your slope. I think I prefer everybody just to count them going down. So now let's do this side. That goes up by 1. That goes up by 1. That goes up by 1. And that goes up by 1. So the slope between these 2 points is a negative 1 over 3. The slope between these 2 points is a negative 1 over 3. A negative 1 over 3. And a negative 1 over 3. So if all the points here in this table have the same slope, it means they are linear. So here you would write yes. Okay, let's go to the second set. So let's find the difference between these two. It looks like it's going down by 5. That's going down by 5. That's going down by 5. I missed this one, and that's going down by 5. So each one of these are going down by 5 from one x to the next. This one is going down by 8. Going down by 8. Going down by 8. And going down by 8. Okay. And one thing I forgot to mention on the first part of number 4 is that when you write your slope, it's going to be the change in the y's over the change in the x's. So this has to be a negative 8 on top and negative 5 on the bottom. So don't forget that, because it's either these slopes are either going to be right or wrong. So negative 8 over a negative 5 gives me 8 over 5. 8 over 5. 8 over 5. 8 over 5. So all the slopes are the same. Because they're all the same, then this has to be linear. Okay, let's go do... Let's see, did I do that one wrong? Yes, I did. If you come back here, I made a mistake on this when I was just looking this over for just a minute ago. And maybe some of you caught me on this. Look right there. That slope goes up by 2. Since that goes up by 2, what should happen here? That should be 2 over 3. So now if you look here, these slopes aren't the same. They're not the same, are they? So this point is not linear with the rest of them. So this thing here should be a no. I hope some of you caught that. You should have been screaming at me. They're from your chair at home or wherever you're at. So this should be, this is not linear. And the reason why it's not linear, this slope is twice as big as these other ones. It's twice as negative slope. It's going down twice as much. Okay, so sorry about that. I kept looking at that and say, that ain't right. Okay, let's finish this last one over here. So this one goes, that goes up by 5, up by 5, up by 5, and up by 5. 8 plus 5, 8 minus 3 gives me that negative, gives me that 5, so that's down by 3. For difference of 3, and I'm going down, so that's down by 3. Difference of 3, 2 to 0 is 2, and then from 0 to a negative 1 is 3, so that's going down by 3. And then a negative 1 to a negative 4, that goes down by 3. So these slopes is a negative 3 over 5. So that is a negative slope. Are all these the same? Yes, they are. So I'll let you do this last one on your own. These slopes are all the same, so are these linear? Yes, they are linear. Okay, I've got, we're going to do parts A and B on 5 next. I'll just pause this video and then we'll go on to problem number 5. Alright, problem number 5. We are doing some graphing on some lines. It says, rewrite the following equation in y in terms of x. Calculate a table of 3 ordered pairs and graph and label the lines for each equation on the coordinate plane. Simplify all fractions to the lowest terms. So let's go ahead and look at this first one. We know the first thing that I need to do is get rid of the x term. So this is a negative 4x, so I want to add 4x to each side. So that's gone. It goes to 0, right? Now we divide by the coefficient of y. Now be careful on this. There's a lot of negatives here. So make sure that if you're dividing two negatives, you make it a positive. So now let's see what our final equation is. I got y equals, looks like a negative 2 over 3x plus 3. Now how did I get 2 over 3? Well, I have 4 over 6. I can divide the 4 by a 2 to get 2, and I can divide 6 by a 2 to get 3. So that's what we want to use for our slope. So now we go over here. We choose multiples of 3. So I'm going to choose 3, 0, and a negative 3. So now I put a negative 2 thirds. I'm going to put a 3 in for the x. That gives me a negative 6 over 3. So that means a negative 6 over 3 gives me a negative 2. So negative 2 plus 3. Is that right? Got the wrong paper here, I think. Well, anyway, yeah, this is right. That should be a 2 there, not a 3. Let me change that. There we go. So negative 2 plus 2 gives me 0. Now let's do this next one. The next one's easy, right? If I have 2 times, that gives me a 0 there. 0 times anything is 0, right? If you want to look at it a different way, negative 2 times 0 is 0. 0 divided by 3. 0 divided by 3 is also 0. So 0 plus 2 gives me a 2. And now let's do the negative part. Negative 2 over 3. That's a negative 3. Well, that's 6 over 3 gives me a positive 2. So that'll give me a 4. So this work right here, you don't have to show me this work right here. You can do that on a piece of scratch paper if you want, but I do want to see these numbers in there for your quiz, so don't get lazy on me here, people. Alright, so now we're ready to graph this. I tell you what, let's go ahead and figure out our other equation and then we'll graph all these together. So now remember, that is a negative 1x. Okay, you see what I'm telling you here? That is a negative 1x. It's a negative 1 there. So I'm going to add 1x to each side. So that's gone to 0. Then I'm going to divide by the 3 to everything. So my equation is y equals 1 over 3x plus 5. So now I can choose multiples of 3 again. I can choose 3, 0, and a negative 3. So 1/3 times 3, that'll give me 1. So I have 1 plus 5. That 5, this 5 comes from there. So that gives me, it should be, yep, that's right, 1/5. That should give me a 1 plus 5 is 6. Now let's do the next one. I got 1 over 3 times 0. That equals 0 over 3, which equals 0. So 0 plus 5 is 5. And the last one, I use a negative 3. 1 over 3 times a negative 3. That equals negative 3 over 3. That equals a negative 1. So a negative 1 plus 5 gives me 4. So now we're ready to graph. So we've got 3, 6, 0, 5, and negative 3 and 4 for that ordered pair for line B. Then we have 3, 0, 0, 2, and a negative 3 and 4 for the points for line A. So let's go ahead and graph line A. So we go 3 on the x-axis, 1, 2, 3, and then we don't go up anything on the y. Now here I don't go anywhere on the x-axis, but I go up 2 on the y. And then here I go to a negative 3 on the x, and I go up 4 on the y. Okay, so there's my graph. Now let's go ahead and mark our points. So we've got that right there, and we've got this right here. That back where it's supposed to be, there we go. And it should go through that center point. So there we go. It goes through all those points. Go ahead and label this A. There we go. Alright, now let's go ahead and graph B. Let me erase this stuff right here. I don't need that anymore. So we'll do this one in blue, light blue. So we got 3 and 6. So 3 on the x-axis, 1, 2, 3, and then 1, 2, 3, 4, 5, 6 going up in the y direction. 0 and 5, 0 on the x, 5 on the y. And then I have a negative 3, so 1, 2, 3, and then 1, 2, 3, 4. So now our line goes through these points. Let's go ahead and get our ruler out. There we go. There's our line for B. So you'll have parts C and D to do to help you with your review. And so remember to show your work in here. The calculations we did down here, you can go ahead and just do them on a piece of scratch paper. I do want to see your equations, and I do want to see the work up here. Make sure you show me that. And then you'll be graded on your graph. I'll probably give you 1 point for each one of these ordered pair. And I'll probably give you 2 points for this and 3 points for the graph. Something like that. Maybe each one of these will be worth 10 on the quiz. So good luck with your review tonight, and we'll see you Tuesday. And then Wednesday is the day before Christmas break, and I think our school has something else planned for us that will be fun. Thanks for tuning in. Bye-bye.